Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're going to be spending a little bit of time kind of getting our metal planer up and running again. It's been a while since I've done anything with this. This is a machine that we restored several years ago. Quite honestly, it was a machine that probably just should have been sent to the scrapyard. It was in such bad shape. But after a lot of tender love and care, we got this machine tuned up and kind of brought back to life. And she is in as good a shape as probably ever was, even when it was new right now. Haven't really used it a whole lot since I've done it, but I do have a project coming up here real soon that we're going to be using this on. And before I get that on there, I want to take some time to kind of just check everything out on the machine. I'm sure that belts are going to have to be tightened up. They've been sitting here stretching out for a while, haven't been ran. I really want to get some metal up on here and do some kind of test cuts with it, just kind of trying to just get used to using the machine, I guess, more than anything else, and kind of learning the machine a little bit before we go and actually use it on a real project that's going to be critical and has to be right. So that's kind of today's goal. I did come over here just a minute ago and kind of declutter it. It had turned into a horizontal surface, and horizontal surfaces in shops, they get covered up. So I had to come in here and kind of clean everything off of it. But now I think what I'm going to do before I do anything else is just kind of get a rag and just kind of wipe everything down, get all the dust off of it, particularly on the ways, to make sure that we get those cleaned up before we start running it, and fire up and see what needs to be done. And let's play with this machine a little bit today and get her ready to roll. All right, step one, clean. Just take a little degreaser here and squirt it down and then wipe it up, mostly just trying to get dust and stuff off of it more than anything else right now. I haven't used this machine in a really long time, and it has just accumulated lots of dirt and stuff out here in the shop just sitting here, so we want to get it cleaned up good. If you didn't watch the series, we restored this metal planer. When I got it, it was in really, really poor condition. It had been used and abused for probably 100 years. And the wear on the bed of this thing, I mean, it was bad. Big, huge gap here in the middle. The table was rusted on the top. The ways were wore out on the bottom. And I actually took this machine apart. I sent the bed and the top off to my grind shop up in Milwaukee, Connecticut, and they re-ground everything and got it trued up. In fact, I went up there, I carried it up there. There's some video of us getting that done with Cash Masters up there, who did an outstanding job on it. And then we brought it back in and started reassembling it and re-scraped the bed, re-scraped the bottom of the table. The top was just ground flat, parallel to everything. And we had to take off, I don't remember how much material we had to take off, but it was a significant amount of material just to get this thing cleaned up. But at the end of the day, she is in excellent shape now. And when this machine was new, it probably wasn't even scraped. It probably was just ran on a big planer and put into use. So it's probably in better shape mechanically, at least from an accuracy standpoint, than it probably was when it was new. Let me finish cleaning this thing up a little bit. Now, when this machine was new, it was line shaft powered. So there would have been a line shaft that ran through the shop that would have been connected to a steam engine or something like that. The line shaft would have been the power source for all the machinery in the shop. So you would have had a single line shaft or multiple line shafts that are all belted up to one another, and then there would have been belts coming down to the individual machines. That's how things were done back before they had motors on every single machine in the shop. This machine was built probably in the late 1800s, and that would have been the way it would have been done. I didn't want to have to put a line shaft in my shop. Actually, I think it'd be really cool to have a line shaft in the shop, but from a practical standpoint, I wanted it to be a self-contained machine. So we mounted a motor back here behind it and basically put a counter shaft up on the top. This counter shaft that's up here on the top with the pulleys on it, that would have been originally mounted in the ceiling, and that would have been belted to the line shaft. So this would have been the counter shaft that ran this machine, the belts coming down to the machine. It's got 2 sets of belts that power the table. There's a big bull gear up underneath this table on a rack and pinion, and it basically moves the table back and forth. There are some trips over here on the side that will shift a belt shifter in there. On these belts coming down, one of them is just going directly around. The one over here has a half twist in it. So the pulley down here on the bottom on this side is running in the same direction as the counter shaft. Because this one has a half twist in it, the pulley on here is running in the opposite direction. Down here on the bottom, there's a tight and loose pulley. Basically, one of the pulleys is just constantly spinning. It's not keyed to the shaft. The other pulley is keyed to the shaft. And so when the belt is on that loose pulley, it's spinning. It doesn't actually engage anything. When the belt shifter shifts the belt over to the tight pulley, it will engage the shaft that's running the bull gear back and forth. And again, with the gear over here on the side, or the mechanism on the side that's going to shift that belt whenever you get to your stops, it basically moves the belts over from forward to reverse, and this table goes in and out. This being a metal planer, similar to a metal shaper in that you have a single point tool here, kind of like on a lathe, but instead of the work going round and round, in this case the work is moving back and forth. On a shaper, you got an arm that's moving back and forth. On the planer, the tool stays still and the work moves beneath the cutter. The planers were made for doing larger work where it would have been impractical to have an arm go out that far. You actually move the entire table up underneath it. And some of these metal planers could be absolutely huge. I mean, big enough that you could put entire locomotive frames, like steam locomotive frames, on that planer and be able to machine that entire frame with the whole bed moving back and forth up underneath it. They were incredible machines, very versatile machines. Their downside to them is they were slow. They actually were very accurate machines, particularly at the time. They were eventually kind of more or less replaced once rotating cutters came into play, milling machines and stuff, more or less made these obsolete. And mainly it was because of a time issue. You could just do it much faster on a mill than you could on a planer type machine. But they're pretty cool. So let's fire this one up. All right, we are slowly turning our belts up there, and you can see the table moving. Now our belts should start shifting. We'll get to the second shifter. There we go. I will note that the forward cut, the cut that we're making right now, is slower than the back cut. The other cut, the tool is actually on a clapper box here, so it's not engaged whenever it's on the opposite cut. So whenever we come out here, it's going to actually do that one a little bit faster coming back. Save time. I've got this set up at variable speed so we can kind of adjust how fast things go. But it appears to be working. So this is the dog system that moves the belt shifter back and forth. You can adjust these stops wherever you want to determine your length of stroke. It's going to come in. Whenever it gets over here, it's going to shift this. When it does, it moves this belt shifter back and forth. Again, you got 2 pulleys on here. The tight pulley and a loose pulley. This outside pulley is loose. It just spins. Now it's just spinning. It's connected on the other side, and that's what's driving it. Got the same thing going on over there, so whenever this belt shifts, it moves it from one side to the other. All right, I think to play around here a little bit, I've got a straight edge casting. This is an 18-inch straight edge casting that was done by Windy Hill Foundry. This is one of our new straight edges that we will be offering for sale soon. This is actually one of the prototypes, and I've been needing to get it machined anyway, so what better time than the present. I think what we'll try to do is plane the bottom of this and just play around with it, kind of fine tune things and get to know this machine a little bit. I have put a big shaper vise up here on the planer. That seems to be the best thing I can find to just grip a hold of that back side of that camelback straight edge there. This shaper vise was actually given to me by a viewer a while back, and I'm going to tell you what, at least in this sideways configuration, it's only got about an inch to spare before it hits the uprights. Now, if I was doing it normally where you were doing it against the jaws like you normally do when you're shaping, I'd have plenty of room to use it in here. But anyway, we're going to try this. I had to kind of raise up my cross piece here to get the clearance where everything will clear up underneath the bottom. I've got my stops brought in here. I've been just messing around with a few adjustments and what have you, trying to get things fine-tuned. I haven't actually made a cut yet, and I think we're ready to do that now. Again, I'm kind of expecting belts to slip and everything else once we put a load on it, but we've got to start somewhere. So let's get in here and see what we can do. So let's see. I'm going to start by, I'm going to crank that cutter back across the other side. And actually, I think I'm wanting to just drop it down a little bit to where it's just making a cut. And I'm going to make a real light pass this first pass, just kind of see how things go. And that's going to probably just barely be touching, but that's what I want right now, is just to barely be touching. And then we can kind of go from there. You want to try it out? Let's try it out. We're not even touching yet. It should barely start touching kind of in this high spot where the two patterns came together and they ground off that little area there. This has some draft to it, but I'm just trying to sneak up on things. So actually, it looks like it touched a little bit right there. Let's see what happens this time. Yep, made just a little bit of a cut. I think I got 2 quarts of a feed going here. I do. I'm going to let it just cut across this first pass. We'll change our step over a little bit on the next pass. I'm just kind of watching this and kind of learning as I go here. I haven't used this machine very much at all. Which is why I want to kind of practice a little bit on another part before I go do something that's a little more critical. But all in all, this appears to be working pretty good. Now I need to kind of figure out what the limits of my depth of cut are and that kind of thing. But so far we're doing good. I'm going to try something new here. I have never actually used this tool that I put in here. This is a tool holder that has some early style indexable tooling. Not like the carbide index tooling we have now, but basically these have little serrations on the back, and you basically have different types of cutters that you can put up into this tool and hold for doing different things. This would be for probably going down a side of a piece over here if you were doing something straight up and down. This one's got a really large radius on the bottom, should give us a little bit smoother of a cut coming across there. I'm gonna give it a try. Like I said, I've never actually put any of these on the mill before, and we're gonna try them out. This is, see, I see at the top of this one, HA8CHH Apex 3F2. So I guess this is an Apex tool company. I think it says OK Tool Company is the name on the holder. I've got a few of these types of inserts that go in here. I actually have another bunch of inserts that are smaller, but I don't have a tool holder for it, but I got a tool holder for this. You know, anyway, I've never used it. We're going to try it out, see how it does. All right, I'm going to start out here by getting the machine going and just barely make a light cut. Pull that cutter out. Like I said, I've never used this tool before, so not sure what to expect. This tool was given to me by Lauren Langdon a couple of years ago. He sent these to me. Some surplus stuff he had laying around his shop that he didn't have a need for. And today's the first time I've actually had a chance to use it. All these old planers had automatic hopper or clapper boxes on them that would automatically lift coming out of the cut. I might have to rig something like that up eventually. So your tool doesn't drag going back across. Well, that's a nicer finish, but still not the finish I'm looking for here. It seems like it's just tearing it more than cutting it. I'm gonna have to play around with my cutters and see if I can find something that does a little bit better than this. I may go ahead and take a couple more passes and just get this roughed out flat, and then switch over to something else and see if I can get more of a flat planing surface on this and get it a little bit smoother. For roughing, it's fine, but I'm shooting for a better finish than that in the finished product. You can see the ways here that we scraped in on both the top and bottom. They're V-ways, double V-ways, everything's matched up really nice on this. And we got these way wipers here on the end. See chip strengthening come in here. You got a physical thing that pushes them out of the way, plus you got the felt up in here that's wiping back and forth. And we soak this felt with oil, and that's what kind of helps keep things lubricated. Also have modified this from the original where we actually have oil being pumped in to the center part, and of course that's going to work its way out as you go. And of course we've got little oil cups here on the end. Catch the excess oil so it doesn't make too bad of a mess. This one is powered by a rack and pinion system. You can see the big bull gear down there on the bottom. That's engaging a rack on the bottom of the table that moves things back and forth, and there's gear reduction going on back down in the bottom to reduce the speed down to what we got going here. You know, later model metal planers were hydraulically powered. They were much smoother, produced a finer finish. But in these early ones, everything was mechanical. All right, guys. There we go. Attempt to take a little bit heavier cut than what I've been taking with this. Let's see how it does. That heavier cut actually seems to be working a little bit better. Pulling a better chip. I know these planers are made to take heavy cuts. A lot of your more modern planers have a clapper box that has a lift feature in it that automatically lifts the tool when it's retracting. This one here, the tool just drags across. I'm just manually lifting it here, seeing if that helps a little bit. That's just peeling that cast iron right out of there. Looks good. Finish might be a little bit better too. I think after this pass, I'm going to go to a different cutter, more of a planing cut, flat cut, just see what it does. So that's actually not too bad. I'm gonna put that flat planer cutter on it and see what that does. Still got a little bit of hardness on these edges. I really need to go down deeper to get below the chill on the cast iron on this. But again, I'm just playing right now. So I think what I'm gonna do is I'm gonna change out cutters and see if we can make more of a planing cut across this and try to smooth it up. Finish cut, basically. This is more of a rough cut here. All right, so here's a cutter that I got over there that's got more of a flat bottom on it. This is for a finished planing cut. I don't know what it's going to do. We're going to see. I'm going to put a pretty light feed on it, but I want to step it over pretty quickly. So I've increased my step over. I think I got a pretty light feed on it. Let's see what happens. We're going to give it a try. Here we go. I think I need to take a little bit more of a downward cut. Cutting pretty nice. I'm pretty happy with that. That is a nice surface. You know, it's obviously not a ground surface, but that is going to be a nice flat surface, I think. It's just shearing that metal right off, which is what it's supposed to do. I could probably take a little bit wider pass. We may try that on the next pass. Take a little bit more of a step over. That is getting better. There's still a little bit of chatter in there. Not getting quite as smooth of a finish, but it seems to be pretty darn flat. And I like that step over in there. That kind of looks a lot like what you see on a lot of old plane surfaces. I think I might see if I can come up with a different cutter again to do this planing cut that's maybe take some of that chatter out. All right, guys, I have ground a high-speed steel planing cutter here. We got this set up in one of our Armstrong holders, and we're going to give it a try. Like I said, we're just playing, learning this machine, trying to figure out a few things, practicing on it, playing on it. So let's give that a shot and see how that does. Well, we had a little bit of trouble down here. This corner has got a little hardness in it. You see a little kind of white area. I probably need to get down below that a little bit more before I do these finish cuts, but I'm still getting a little chatter in there. More chatter than what we have with that other cutter. I think I'm going to change my geometry of my cutter here a little bit and see if we can improve this. Let me play with that. I'll be back. So guys, I've tried to kind of copy the geometry of this insert cutter a little bit better. I don't have quite as much angle on the bottom. I got a little bit more angle on the face here. And the other thing that I did, I don't know if you can see this or not, but this is at a little bit of a back angle. So I've got a little bit of a raking angle on there as well, which I read in some of my books. If you kind of have a skew on it, it works better on these planing cuts. So anyway, we're going to give this, I'm going to hone that up with a little stone real quick. I did most of this over on my belt grinder. I just have a little bit more control than I do on a wheel grinder. So we're going to give that a shot, see how it looks. Looks better. I'm going to come across it again, just making a real light cut. got you guys zoomed in here, and you can see a little bit of a pattern in there where it's just kind of got a little bit of a chatter going across it, but it's not terrible at all. But I've seen much better surfaces on a plain surface. And honestly, I think that part of the problem that we're going to have with this machine is because it's a rack and pinion driven machine, every time those gears are making contact down there, you're getting a little bit of vibration into the surface up here. That's just a known issue with these old antique rack and pinion driven things. The later planers were hydraulically powered. You had a much smoother stroke and you got a smoother finish, as one would expect. But I'm pretty happy with that. I mean, that's not a bad surface right there at all. I feel like that I could take that and start scraping it right off the planer. Anyway, yeah, I'm pretty happy with that. Well, there you go. It's not every day you get to play around with a machine that was built and designed and really used in the late 1800s, but this is such an example. And I think I've said it before, I'll say it again. You know, in today's modern world, computer-controlled machines and everything else, this machine is obsolete in many, many different ways. But with that said, there are still applications where a shaper or a planer does a good job. And in a job shop, like what I do, making one-off parts, having the flexibility to be able to use a machine like this can save your tail when you don't have the right machine to do a job on. You don't have the right piece of equipment in your shop. You know, and if you're not in a production environment where it's all about time and cranking out multiple parts over and over and over again, even though it's slower, even though it's a little bit of an older technology, it'll get the job done and it'll get it done well. And with that said, there are still metal planers that are in use to this day in production jobs where you have really long parts that have to be machined out really nice and flat. And the practicality of getting a machine large enough to do that, particularly on something that's a job that's not coming up real often, you know, it doesn't always make sense to upgrade from a machine that's getting the job done and that's paid for and have to go spend hundreds of thousands of dollars on a machine that maybe doesn't get utilized to its maximum. So, you know, there is an argument that there is still a place out there for these. This is a toy for me. But it's a useful toy, and it's a toy that it comes in handy from time to time. It comes in handy for jobs, you know, maybe not, this would not be the ideal way to machine this. This is a way to machine this particular straight edge, but you know, for the job I got coming up on it, I haven't been able to do it on any other machine, so we're gonna give it a try on this one and see if we can get it done. All right, guys, we're getting out of here with that. That is a wrap. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted to the site. Big, huge thank you, as always, to those who support the site financially through Patreon and PayPal. There's links for that down below if you feel like it's something you can help out with. It really helps me be able to take the time to shoot these videos, edit the videos, do everything else that goes along with it. And with that, we are going to sign off. We will catch you on the next video again. Thanks for watching.